Hello everyone. Today's video I'm going to make a discussion of linked lists and a review of pointers. And as we all know, pointers are data structures that are used to create the to create an implementation of linked lists, but pointers are not really required to create an implementation of linked lists. You can use other data structures like array indices, but the easiest way would be pointers. So in this video, I'm going to make a discussion of linked lists, how to create a simple code that will implement linked lists. But before that, let's have a short review of pointers. And as we all know, a linked list, from the word itself, list, it's a collection of related items. So basically, when you create a linked list, you're creating a chain of lists that are connected with each other. And the fundamental operations of list or linked list in general are add items and delete items. And in a linked list, it is actually a data structure that uses pointers, just like what I told you a while ago, to connect individual lists of elements. So you have many lists, and you connect them with each other using pointers. They're connected with pointers. And it has three parts. Linked list has three parts. The first one would be list head, data members, and the third one would be the pointer. So if I'm going to make an illustration, if we have, let's say, a list head over here. So let me create a simple illustration of a linked list. So this is basically how a linked list would look like logically. So this is going to be your list head. This one is your list head over here. Which means that it is the beginning of the linked list. It's the head of the list. And the data members here that we're talking about are the values inside that list. And the pointer is it gives access to the next data members. So basically this one is the pointer. It points to the next list. And just like what I told you a while ago, creating linked lists requires a clear understanding of pointers. And what are pointers? Pointers are actually variables. They're just variables that contain the address of a variable. So if, let's say, I have a variable here, a, which has a data type of integer, and you put 50 into that, how does a computer actually stores that variable? Now I have here a logical representation of a RAM. Okay, let's say that, let's just imagine that this is how logically RAM is designed. Okay, so if you look logically at the RAM, basically when you use variables, you use a portion of RAM, a portion of your computer's memory. And if we go back here, okay, just like what I told you, we have used a variable a, which has a data type of integer. We put 50 into that, and how it looks like in the computer memory is something like this. It may go to 4010. This is 4010 would be the memory location, a would be the variable name, 50 would be the variable value. Now there is no way for us to know exactly where in the memory this variable is going to be, because we are dealing with RAM, random access memory. So it could be in 4010, it could be in 4008, it could be in 4006, but we're sure that it's going to act randomly. So as long as the space is empty, that is. So if we assume that this space over here was empty, then a would be put into 4010. So, but it could be in 4008, it could be in 4006. Remember, we are dealing with RAM. So, basically, when you put something, when you use a variable, you you use a portion of the RAM, you use a location in the RAM. So this location over here, which 50 occupies, you can actually call them by their memory location, or you can call them by the variable name. But you know, we programmers, or you programmers, actually we are more comfortable with or human beings in general, we are more comfortable with calling a person by a name rather than by their, let's say, their student number. It's not normal for a person to call your classmate by their student ID. We're more comfortable by calling a person by their name, so it's easier that way. So as a programmer, it's easier for us to, you know, to call somebody by, or to call a variable by the variable name instead of its memory location. But there are several reasons why you wanted to use a pointer, because it could be that it's much faster, especially in a larger program. It could be it's much faster to access a value with its directly in its location than its variable name. And of course, the other reason is you use pointers, you access the memory location for you to use linked list, just like what we're doing now. So that's how you store a variable. Now, whenever we use pointers, we actually use two types of operators. Number one would be this ampersand symbol here, and we call that the address of operator, and it indicates the address of a variable. And the next one would be the asterisk symbol, which is the dereference operator. And this one, it points to the content of the memory address contained in the variable, and it can be read as value pointed by. So if we are using this this operator here, address of operator, we are actually referring to the address of the variable that we are pointing to. And if we are using the reference operator, asterisk, we are actually referring to the value inside of that address. So to make an to create an example, or to present you an example, so I have a very simple example considering the following. So I have here a variable which is integer. We assume that this is integer, and integer my var is equal to 36. So basically we put 36 into this variable, and we have a pointer. Okay, addr var, or address var, is equal to ampersand my var. So which of the following is true? So remember, this is just a regular variable. My var is just a regular variable, and addr var is a pointer. Okay, so what I'm trying to tell you is, remember we use this ampersand operator, or the address of operator. So meaning we are trying to, or we are putting the address of my var into the variable addr var, or into the pointer. This is a pointer. Okay, so that's a pointer. And which of the following is true? So number one, is my var equal to 36? Number two, is ampersand my var equal to 1554? So we are assuming that the address of my var is 1554. Okay, number three, is addr var equal to 1554? And number four, is asterisk addr var equal to 36? Now I want you to determine if it's true or false. Now you may pause this video, and you may try to solve it on your own and probably take notes. Okay, so after you have tried to answer this simple challenge, now let us try to evaluate your answers. So number one, is my var equal to 36? Is that true or false? Now remember, in this line, we are putting my var, we are putting 36 in the variable my var. So this is definitely true. Okay. Number two, is ampersand my var equal to 1554? If we go back, Address of operator ampersand indicates the address of a variable, and the address of my var is 1554. So is the address of my var equal to 1554? Yes, that is true. Number 3, ADDR var. Is ADDR var equal to 1554? If we go back here, okay, ADDR var is a pointer, and we are trying to put the address of my var. And if we go back here, the address of my var is equal to 1554. And so number 3 is also true. For number 4, is asterisk ADDR var equal to 36? Now remember, if we go back to my previous slide, the reference operator, it points to the content of the memory address contained in the variable. So if the value of ADDR var is equal to 1554, we are putting the address 1554 in this pointer. And if we put an asterisk before this pointer, it means that we are not referring to the memory location anymore. We are now referring to the content inside 1554. And 1554 is the address of my var, which contains the value 36. So if we are going to draw a logical representation of the variable, so that would be, this is 36, and you can access 36 using 2 ways. You can access the value using the variable name myvar, or you can access this value using the address of myvar, which is 1554. Okay, so let me show you a sample code of implementing a pointer. And I'm using an iPad, and I found a great app if you are using an iPad or using an iPhone. This is Mobile C, and you can download this for free in App Store. I have a Mac as well, and I'm using Xcode in Mac, but I have a pretty low storage now on my Mac. So, and in addition to that, I can use this slide, the PowerPoint presentation, using my pen here, my virtual pen, and it's easier for me to discuss videos with annotating the slide. So let me show you how to implement the pointer in a code. So I have here, I'm inside the main procedure, and let me show you how it's done. So if I have, let's say, a variable, let's say my input, and that is an integer, and I'm going to declare a pointer. So let me name my pointer as my pointer. So here in line number 6, I have a variable that is an integer. The variable name is my input, and I have a pointer which the name is my pointer. Now the characteristic or how you determine a pointer is you put an asterisk behind before the pointer name. So if a variable name has an asterisk before its name, then it's a pointer. And the next thing that you have to know is you have the pointer which will contain the address of another variable. They should have the same data type. Okay, so since I'm intending to put the address of my input into this pointer, then they should have the same data type, which is they should be both integer. So this is our pointer, and this one is our regular variable, line number 6. So let me try putting a sample value here. So my input, for example, is equal to 5. That's an integer. And let's use our pointer. My pointer is equal to my input. Okay. Now, if you want to store the address of this variable, then you have to put the ampersand before the variable. So you're putting the address of my input into this pointer, my pointer. Okay, so let's try to output cout, and then let's try to display the value of my pointer. Okay, so let's try to run this program. Now remember, we are putting the value of 5 here in line number 9. We're trying to put the value 5 into the variable my input, and then in line number 11 we are trying to put the address of the variable my input into the pointer my pointer. So let us try to see the output. Okay, so the output here is 0x2839A2150. Now if you are trying to also run this code in your own computer or into your own gadgets or devices, you may get a different output than mine. That is pretty much normal, because just like what I told you earlier, whenever you use variables, variables are pretty much stored in computer's memory, in computer's RAM, and so you might have a different address than what you are seeing here. So this is 0x. 0x, it's if you see a number that has 0x in the beginning, then it means that it is a hexadecimal number. And if we are dealing with computer or in memory locations, we usually refer to memory locations in RAM. We deal with them with hexadecimal numbers. Okay, so memory locations are actually represented in hexadecimal numbers. So this is 0x2839A2150. Okay, now what would happen if I put an asterisk? So if I put an asterisk before, if I put an asterisk before my pointer, then it means that we are not going to display the address that is stored inside my pointer, but instead we are going to display the content of the address that is stored in our pointer. So if we run the program, then what would be the output? Is it going to be another memory address, or is it going to be 5? Now the correct answer would be 5. So remember that we are trying to put, okay, let me go back in our code here. Okay, so again, in line number 9 we are putting a value of 5 in my input, and line number 11 we are putting the address of the variable my input to my pointer, and line number 13 we are displaying, since we changed it or we added an asterisk before my pointer, then we are trying to display the content of my pointer. Okay, so let me show you another let me show you another challenge here. Just change it. Oopsie. All right, so since I'm done with showing you how to code a simple pointer, then I have a simple challenge for you guys who are watching this video. Now remember that this discussion, this tutorial is part of a playlist of a linked list playlist. So if you want to if you want to have a continuous learning, continuous tutorial about this topic, then you might want to check my channel and then check the playlist there that I have created for this tutorial, linked list discussion / tutorial. So basically my challenge is, number one, you have to create a float, or you have to create float variables and name them mynum1 and mynum2, and you have to save their memory addresses to pointers addrnum1 and addrnum2. Now remember that a while ago I told you that if you want to create a pointer for a specific variable, they have to be, that variable and that pointer should have the same data type. So you have two float variables here, and so your addrnum1 and addrnum2 should also be both float. And the second instruction would be, you are going to ask the user to input values for these variables, but you are going to store the values in the memory addresses of these variables, okay? Not in the variables themselves. So normally when you're trying to input a variable, let's say you're going to input something in mynum1, then by the way, I was using C++. So if you're using C++ too, then probably the step that you would be doing would be cin and then mynum1 to put value in mynum1. So that is going to be wrong for this challenge. What the instruction says is you have to put the values directly into the memory address of the variables mynum1 and mynum2. Okay, and this is the sample output. So the first input is 3.2, that is coming from the user, and the second input would be 1.6, and it's going to show the values that the user inputs with the first number and the second number. So basically it's just repeating it's just showing what the user has input in the variables. Okay, so that's for the challenge, and in the next video on this playlist I will show you the solution. Okay, so see you in the next video.